All right, let's jump right into this. I want you to take a second and think back to your very earliest memory. Really try to picture it in your head. Chances are you were what, maybe 3 or 4 years old, right? But here is a pretty wild reality to consider. You lived an entire, incredibly rich life before that age. I mean, you were born, you opened your eyes, heard your mother's voice, tasted food, took your very first steps, and even spoke your first words. It was an entire lifetime of firsts, and yet you can recall absolutely none of it, not a single moment.
So, where exactly did those first 3 years go? Now, most people assume the answer is incredibly simple. We kind of just tell ourselves that baby brains are, too young or too weak to remember anything. But that is actually completely false. Your baby brain wasn't failing to record your life. It was, in fact, recording everything. Those memories were successfully created. The real mystery here is that something came along and completely destroyed all that data.
Scientists actually have a specific name for this total memory wipe: infantile amnesia. And this isn't some new concept either. Sigmund Freud was actually the first person to formally name this phenomenon way back in 1905. For over a century now, the absolute greatest minds in psychology and neuroscience have been completely baffled by this. Like, why on earth do we just lose our earliest years?
Well, we know for an absolute fact that babies can form memories. A brilliant experiment from the 1980s by psychologist Carolyn Rovey Collier illustrates exactly how. She ran this incredibly elegant test. Step 1. She tied a little ribbon from a baby's ankle to a colorful mobile hanging right above their crib. Step 2. The babies quickly realized that kicking made the mobile move, and they absolutely loved it. But step 3 is the kicker. Literally. When she brought those exact same babies back days or even weeks later and put them under the mobile, they started kicking immediately. Even 2-month-olds remember the trick for days, and 6-month-olds held the memory for weeks. So they can learn, they can store, and they can recall.
So if that's the case, why doesn't that data last into adulthood? To figure this out, we've got to peel back the mystery. Layer 1 is the hardware problem. Basically, the engine of your memory is this curved structure deep inside your brain called the hippocampus. In an adult brain, it works flawlessly with the prefrontal cortex to tag and store your daily experiences into long-term memory. But in an infant brain, this system is severely underdeveloped. Specifically, there's a gateway region called the dentate gyrus that is essentially unwired until you're about 2 to 4 years old. Because of this missing hardware, your infant brain could successfully form short-term memories, sure, but it completely lacked the physical bridge to move them into permanent, long-term storage.
But a lack of physical wiring? That's really only half the story. Layer 2 gets much, much stranger. We call it building by destroying.
Fast forward to 2014. 2 neuroscientists in Toronto, Sheena Jocelyn and Paul Franklin, uncovered a mechanism that completely upended our understanding of memory. It's a biological process called neurogenesis. In the first few years of your life, your brain, specifically that memory-making hippocampus we just talked about, is producing new neurons at an absolutely extraordinary rate. And this rapid growth is essential, right? These new brain cells are exactly what wire up the lifelong circuits you need to function. But the Toronto researchers suspected this massive growth spurt came with a pretty heavy hidden cost.
To test their theory out, they turned to mice. And the results, which were published in the journal Science, were absolutely staggering. When the researchers artificially sped up neurogenesis, meaning they literally forced the brain to create new neurons faster, adult mice suddenly started forgetting things they had previously learned perfectly. Conversely, when they artificially slowed down neurogenesis in infant mice, those babies held onto their memories much longer than normal. What this proved is that every single time a brand new neuron integrates into an existing brain circuit, it acts like a microscopic bulldozer. It disrupts and severs the connections that were already there. And those were the very connections holding on to your memories.
Honestly, this biological process is kind of a beautiful tragedy. Your brain wasn't too weak, it was just way too busy growing. Think of it like this. Your brain kept building new rooms, and it had to tear down the old walls in the process. The exact same explosion of new neurons required to build your magnificent brain was simultaneously overriding the memories stored inside it. You didn't passively lose those early memories. Your developing brain actively bulldozed them to make room for its own physical growth.
But hey, memory isn't just biology, right? It's also psychology. And that brings us to layer 3, the birth of you.
To form an autobiographical memory, a memory where you can actually replay an event in your head as the main character, you fundamentally need a continuous sense of self. Developmental psychologists Mark Ho and Mary Courage demonstrated this perfectly using the famous Rouge mirror test. If you put a little dot of red makeup on a baby's nose and sit them in front of a mirror at 12 months old, they'll treat the reflection like a completely different child. They just don't know it's them. But right around 18 months, a light bulb turns on. The baby reaches for their own nose. They recognize that the person in the mirror is them, and as it turns out, that precise moment of self-recognition closely tracks with the exact age at which memories finally begin to stick.
The really profound takeaway here is that you can't remember being a baby because, in a very real psychological sense, there was no you yet. Not in the way you experience yourself today, anyway. You have to understand that you exist as a distinct person separate from the world for a memory to happen to you. Without that self-awareness, there's just no narrator inside your head to package those early experiences into a cohesive story.
Which brings us to the fourth and final layer of this perfect mystery, language and culture. Developmental psychologist Catherine Nelson realized something huge. Language doesn't merely describe our past experiences, it actually structures them.
Think about it. Before you could speak, your world was encoded entirely as raw sensory impressions. A bright flash of light, a super loud sound, the soft texture of a blanket, or just a sudden burst of emotion. But without words to organize those impressions, they had nothing to grab onto. Language gives your memory a skeleton. Without a linguistic framework, our early experiences are literally like water poured onto a table with no container. They pool for a brief second in the moment, and then they just evaporate completely.
And if you're sitting there thinking, that's just a neat theory, well, data from Cornell psychologist Chi Wang proves that language literally alters brain retention. The average age of a person's earliest memory actually changes depending on the culture they're born into. In Western cultures, where parents constantly narrate experiences and ask children questions about their day, earliest memories start around 3.5 years old. But check this out. The Maori of New Zealand place a massive, profound emphasis on oral tradition and personal history. Because of that, their average first memories reach all the way back to 2.5 years old. Conversely, in some East Asian cultures where early narratives focus a bit less on the individual, first memories don't start until age 4 or later. The storytelling culture you grow up in literally shapes the physical reach of your memory. It's incredible.
So bringing all these incredible insights together, we can finally close the case on our forgotten first life. Conclusion: becoming who you are.
As we've seen, infantile amnesia isn't just one simple flaw. It's a perfect storm of forgetting. First, your hippocampus lacked the physical dentate gyrus wiring to move short-term memories to long-term storage. Second, an unstoppable flood of neurogenesis physically tore through the circuits that held the memories you actually did manage to make. Third, you didn't have a continuous concept of self to anchor those experiences to a main character. And fourth, you lacked the language framework required to hold those raw sensory experiences together. It was literally all of these things, operating all at once.
Every single human being on Earth has a black hole where the first 3 years of their life should be. But, actually, scratch that. This isn't a failure of the human body at all. Your brain was simply busy doing something infinitely more important than saving memories. It was building the physical and psychological architecture required to become you.
But I gotta say, this leaves us with a truly mind-bending final thought. If you possessed no continuous sense of self, and the brain that experienced those early years physically rewired itself beyond recognition by literally tearing down old circuits to build new ones, is the baby in your old family photos actually you, or is it someone else entirely? Someone who inhabited your body, but whose mind was literally disassembled, destroyed, and rebuilt, neuron by neuron, into the exact person you are right now? Well, I'll leave you to think about that one.